Good afternoon, Elon Musk and the Mars colonization team. I'm Dulamini, and today me and my group will be presenting our project on replacing an existing structure on Earth with an optimal design to be constructed on Mars using virtual 3D printing. For our existing structure, we have selected Long Island Green Dome located in United States. Local Mars material, volcanic rock basalt, is crushed and melted and used as our main building material. Using topology optimization, we have created and compared the performance of the structure. Then the results from the established 3D model will be used to produce a 3D printing. Now I will pass it on to Charlie.
The original internal support is solid with height of 8 meter and width of 7.5 meter. 7.5 from the bottom end is received to a fixed end. The interaction is set to tie two surfaces together. For help within the design domain, the optimization statement of the project is to minimize the total strain energy of the whole system with a Warren fraction of 0.4. Here is the box condition of the optimized design with maximum stress and maximum displacement. In the next part, we optimize the surface of the dome structure with Bezier 2D. After changing the value of a filter radius and objective volume fraction using Bezier 2D, there are 4 different results from client to choose, and we choose the second one and create the 3D model.
Since the 3D printer we will use has a nozzle diameter of 0.1 meters, we have chosen to print the partition walls of all components of the dome at 0.5 meters thickness. Our printer of choice on Mars will be the MakerBot Replicator 2 from Meshmixer, which will print the dome using volcanic basalt rock found on Mars. The supports required to print the dome from the bottom upwards are shown in purple. Finally, this is the 3D renders of our dome structure from different angles. The dome is also rendered to show what it would look like on Mars.
For our group, I think there are 5 main merits. Firstly, we plan to use 3D printing technology to build colonies, and the material basalt is easy to find in Mars. Secondly, topology optimization allows the structure to achieve the required strength with less material consumption. And the structure we design will let people leaving the house can easy to pass, and we believe that the optimized structure can give people a sense of beauty, so that people leaving the house will feel more comfortable.
In conclusion, we can conclude that the combination of 3D printing and algorithm help to provide a good plan for Mars colonization, but this plan may have a few limitations. There are 2 main concerns here, which is construction materials and post-maintenance. We have faced some limitations such as limited resources, different printing materials from Earth, no standard specifications, and lack of design for printers used in space. Expectations. Further research and analysis steps need to be taken, and also a lot of preparation and prior planning is needed to be colonization of Mars in order to complete the design of the entire colony successfully. Thank you for your listening.